Coming to another model in first order differential equations, we have Riccati's differential equation. Clearly, you can see here the dependent variable y is in power 2, hence it is a non-linear one. Non-linear first order, of course. Okay, only dy by dx is there. Non-linear first order differential equation. Okay. Also, in this Riccati differential equation, if you observe, if r of x, if I take it to be 0, then this equation turns out to be Bernoulli's. You can clearly see it turns out to be a Bernoulli differential equation. It would be Bernoulli's differential equation, right? Okay. Okay, so we'll consider the case when r of x is non-zero. How to handle such a differential equation? If r of x is not equal to 0, then what should I do? It's not easy to solve. It is not easy to solve. So what do I do? I'll assume that the general solution to 1 would be of the form. I'll split it into two parts. Would be of the form y is equal to v of x plus 1 by z. Okay. Now here, I'll be knowing one solution in this. Okay, I'll talk about it, but let me finish off writing. Actually, this equation requires dy by dx. So I'll be differentiating this 2 with respect to x. Okay, so I'll be getting differentiating 2 with respect to x. What I'll be getting is dy by dx. This is equal to dv by dx. Z derivative would be what? 1 by z derivative would be what? Minus 1 by z squared. Of course, dz by dx. Okay. Z prime or dz by dx is what I'll have. Now here, we'll assume that one solution is known to us. That means what? This v of x, whatever is there, is known to us. Usually it will be given in the problem for undergraduate students. Otherwise, it is for us to find v of x and then proceed with the solution to Riccati's. Okay. So without loss of generality, let me solve one problem on Riccati's so that you understand what exactly I'm talking. Solve dy by dx is equal to y squared minus 2x minus 1 and 2y plus x squared minus x plus 1, where v of x or v is equal to x. Here I will write for your understanding. One solution is known to us. One solution is given in the problem. Okay, for an undergraduate student in the problem, v of x would be given. So I'll proceed with the solution to this problem. Solution. What is the assumption? Let y is of the form v of x plus 1 by z. Then what would be dy by dx? dy by dx would be dv by dx minus 1 by z squared dz by dx. Okay. So what happens is I'll substitute y and dy by dx in the given equation and see what happens. Okay. In this equation, I'll be substituting. So just see what happens. Of course, it reduces to a linear order Bernoulli's equation, and we already know how to solve a linear order Bernoulli's equation. That's the basic idea. Okay. Yeah. So just a second here, what I'll do, I'll be inserting the v of x and then proceeding instead of having all the things to be unknowns. Okay. I'll be directly substituting what is v of x that's been given to me in the problem. Okay. This is nothing but x plus 1 by z, right? So dy by dx is nothing but dx by dx is 1 minus 1 by z squared dz by dx. Okay. So I'll be substituting y and y prime in 1. the given equation. Let's suppose the given equation is 1. Okay. So I'll be substituting these values there. So what I'll be getting? 1 minus 1 by z squared dz by dx. This value is equal to y squared. What is y? X plus 1 by z whole square minus 2x minus 1 into y x plus 1 by z, that is, plus x square minus x plus 1. No substitutions needed because no more y's or y primes are there. Okay, there's a 1 with plus sign and there is a 1 with plus sign which are on either sides of equal to. So I can cross them out. Anything else we will see. First of all, let's simplify and then see what happens. Minus 1 by z squared dz by dx is what I'll have on the left. Right side, x squared plus 1 by z squared plus 2x by z. Okay. And then I'll be multiplying these two things. Minus 2x into x would be 2x squared minus 2x by z. Okay. Now I'll be multiplying with minus 1. So minus x minus 1 by z. Of course, there's a minus outside. So this becomes plus. This also becomes plus. And then x square minus x plus 1. Let's see if anything gets cancelled off. Minus 2x squared plus x squared plus x squared. Okay. Yeah. Also plus 2x by z minus 2x by z also gets cancelled off. Right? Anything else? Plus x and minus x also gets cancelled off. Let's see what are the remaining terms. Okay. So minus 1 by z squared dz by dx is remaining. And what else I'll be having is 1 by z squared will be there. This term is there. This term is there and this term is there. Okay. Plus 1 by z plus 1. These are the terms that I'll be having. Okay. Let's see whether I'm able to write it as Bernoulli. First of all, first order derivative is the highest order derivative. To that, nothing should be multiplied to understand the differential equation. So I'll be taking z squared this side with the negative sign. Okay. dz by dx. Z square goes to the numerator with a negative sign. So minus 1 plus, no, minus z minus 1 minus z. Okay. Yeah. I think everything went off. Oh no, this one went off actually. This one also went off. Okay, so I'll be having, I'm sorry, this is a printing mistake. There's no 1 here. It got cancelled off in the previous step. dz by dx plus z is equal to minus 1. I can clearly see this is a linear equation in z. I'll write here linear differential equation in z. Why? Because I know how to solve it. How do I solve a linear differential equation? Directly write the integrating factor and first write the integrating factor and directly write the solution. Integrating factor is what? P of x. P of x is 1 here. And then Q of x is minus 1 here. Okay, so e power P of x dx. So e power integral x dx would be what? E power 1 dx, I'm sorry, would give me what? E power x. Okay, now how will I write the solution? Z into integrating factor. This is equal to integral Q of x into integrating factor dx plus c. What's Q of x? Negative sign. One only I have. Okay, minus. What's integrating factor? E power x dx plus c. Left hand side is z e power x. Okay. So finally, if I integrate e power x, integration or differentiation of e power x is e power x only. So z e power x, this is equal to minus e power x plus c is what I will have. Okay. So what do? I want the value of z. So what I'll be doing is, I'll be bringing e power x to this side. So I'll be having minus 1 plus c e power minus x. So this is the value of z. Why? Because just see here, y is equal to v of x plus 1 by z. V of x is known to me. It's been given to me as x. Z I should be writing, right? Minus 1 plus e power minus x. This is how I'll write the solutions to Riccati differential equation. It's easy enough. It's easy, provided you know what's the substitution that I ought to make. Okay, this is a substitution. Do remember it and do it little carefully without any errors. Okay, I shall do one more problem on Riccati in the next video.